This is exercise sheet 3, question 8. So in the blue here on top, I've written down the derivatives for the hyperbolic sine, cosine and tan functions. So I worked them out in one of the other videos. It's in some of the other notes that I put up online. So we're going to be using those here to differentiate some functions that were given in this question. So the first one is y equals 5 times sinh of 2x divided by 4 minus x to be squared. So we'll differentiate this function. So straight away, this is going to be quotient rule. So I'll say that's equal to u over v. The quotient rule tells us if y equals u over v, then dy dx is equal to v times du dx minus u times dv dx all over v squared. So du dx is equal to the derivative of 5 times hyperbolic sine of 2x. So it's going to be 5 first of all. Now differentiate sinh of 2x with respect to x. Well, the derivative of sinh x is cos x. So we use the chain rule. We differentiate with respect to what's in the brackets. So that's with respect to 2x. And then we multiply by the derivative of 2x. So we get cos of 2x multiplied by the derivative of what's in there, which is 2. And we get 10 cos 2x. dv dx is also a chain rule. We have 4 minus x to be squared. So we differentiate with respect to the brackets, and then we multiply by the derivative of what's in the brackets. So differentiating with respect to what's inside the brackets, we get 2 times 4 minus x multiplied by the derivative of what's in there is minus 1. So we get minus 2 times 4 minus x. I'll leave that like that for the moment. Now we can do our quotient rule. dy dx is equal to v, which is 4 minus x to be squared, times du dx, which is 10 times cos of 2x, minus u times dv dx. So u is 5 sinh of 2x, and dv dx is minus 2 times 4 minus x, all over v squared, which is 4 minus x to the power of 4. So to the power of 2 squared again, multiply the two powers and get 4. Now when I look, I see that I have a factor of 4 minus x everywhere. So I have 4 minus x here. I'll divide by 4 minus x top and bottom, gets rid of that one. That 2 becomes a 1. That 4 becomes a 3. So now we'll multiply this all out and it'll be done. That's equal to 40 minus 10x times cos of 2x. I have minus 2 times minus 5, so I'll have plus 10 times sinh of 2x divided by 4 minus x to the power of 3. And that's the end. That's part 1. Part 2 is this function here. So I'll just tackle it one part at a time. I'll say dy dx is equal to, so we have 3 times the inverse tan of x. So if I go to my logbook, my maths tables, I see the inverse tan of x over a is a over a squared plus x squared. So the inverse tan of x, when I differentiate it, I get 3 stays there. I get 1 over 1 plus x squared. That's straight out of the maths tables. Minus 8. So I have cos of 3x. So I do chain rule. Differentiate cos, you get sinh. So I get sinh of 3x. And by the chain rule times the derivative of what's in those brackets is 3. The square root of x is x to the power of a half. So it's going to be minus. That power of a half comes down. And I take away 1 in the power. So I had a half, minus 1 gives me minus a half. So it's minus a half x to the power of minus a half. E to the power of 2x. By the chain rule, I get minus 2 times e to the power of minus 2x. So the derivative of e to the x is itself, and by the chain rule I get that minus 2 out in front, the derivative of what's on the top there. So minus 2 times e to the power minus 2x. Finally, 2 times the log of 4x. So I'll say that's plus 2. That stays where it is. I differentiate log, I get 1 over whatever it is. And the derivative of what's in the brackets is 4. So it's going to be 1 over 4x times the derivative of what's in the brackets, which is 4. So now I'll tidy up each of those terms. That first one becomes 3 over 1 plus x squared. Minus 8 times 3 is 24, minus 24, sinh of 3x. Minus a half. X to the power minus a half is 1 over the square root of x. So this whole thing is minus 1 over 2 times the square root of x. Then I get minus 2 times e to the minus 2x. And 2 times 4, well, the 4 is actually cancelled there, top and bottom. And I end up with plus 2 over x. And that's my answer. Next, part 3. Y is equal to root x times inverse cosine of 2x. So first step here is going to be a product rule. So by the product rule, I'll say that this is the square root, well, dy dx is the square root of x times the derivative with respect to x of inverse cosine of 2x plus the derivative with respect to x of the square root of x times cosine of 2x. So that's the product rule. It's this is the first one times the derivative of the second one plus the derivative of the first one times the second one. So that's equal to root x times the derivative of inverse cosine of 2x. If I go to my logbook, I can see that the inverse cosine of x is equal to minus 1 over the square root of 1 minus x squared. So by the chain rule, I'm going to get minus 1 over the square root of 1 minus. Now, in the book it's shown as x squared, but that's for the inverse cosine of x. I have inverse cosine of 2x, so it's going to be 2x to be squared, goes in here. So that's the derivative with respect to the thing in the brackets. But it's with respect to x that I want the derivative. So by the chain rule, I have that times the derivative of what's in those brackets, which is 2. And that's all multiplied. Then the derivative of the square root of x, that's x to the power of a half. So it's just a half times x to the power of minus a half. We had that above. Times the cosine, inverse cosine of 2x. So now we just tidy this up. That's equal to minus 2 times the square root of x divided by the square root of 1 minus 2 times x to be squared gives me 4x squared when I multiply it out. And on the right there I have 1 over 2 times the square root of x as above times the inverse cosine of 2x. And that's the answer. The only tricky part really there is you first have to do a product rule and then you have to do a chain rule inside it there with the inverse cosine. Just in case that inverse cosine part caused trouble, in the logbook I'm given inverse cosine of x over a under f of x, right? And I'm told that f prime of x, or the derivative, is equal to minus 1 over the square root of a squared minus x squared. That's the thing that's in the book, right? So in my case, I can get from that the inverse cosine of x, if I let a equal to 1, is minus 1 over the square root of 1 minus x squared. Then I applied the chain rule, which says that if f of x is equal to u of v of x, then f prime of x is equal to du dv times dv dx. In this particular problem, what I was differentiating was the inverse cosine of 2x. So u is inverse cosine and v is 2x. So du dv is the derivative of inverse cosine with respect to v. So I'll write that down. So by the formula above, it's minus 1 over the square root of 1 minus v squared. And then after that I multiply it by dv dx. Well, if v is 2x, then dv dx is 2. So that's how I got there. I put in 2x again for v, and I got 1 over the square root of 1 minus 2x to b squared times 2. So that's how I differentiated that inverse cosine of 2x above, just in case there was any confusion on that point. Part 4. Y is equal to x to the power of 4 times inverse cosine of 5x. So straight away, product rule. It's going to be the derivative of x to the power of 4 times inverse cosine of 5x plus x to the power of 4 times the derivative with respect to x of the inverse cosine of 5x. So derivative of x to the power of 4 is very easy. It's 4x cubed, and then I just have my inverse cosine of 5x plus x to the power of 4, and now I have to do a derivative of inverse cosine of 5x. Well, this is just like the one I did on the last page. I get my formula for the derivative of inverse cosine from the logbook, and what I get is, I'll put this in brackets, we're multiplying, minus 1 over the square root of 1 minus 5x to be squared. So that's the derivative of inverse cosine with respect to the brackets. Then by the chain rule times what's in the brackets is just, or the derivative of what's in the brackets, I should say, is 5. So there we go, that's 4x cubed inverse cosine of 5x. I put that all together, I get minus 5x to the power of 4 divided by the square root of 1 minus 25x squared. Again, 5x to b squared is 5 times x times x. Next, part 5, another quotient rule 1. 5 times cosh of 3x divided by 4 minus 2x to b squared. So we'll call that u over v. We'll say u is equal to 5 times cosh of 3x. So that means that du dx is equal to 5 times derivative of cosh is sinh, and then I multiply by the derivative of what's in the brackets. So that's 15 sinh 3x. V is equal to 4 minus 2x to be squared. So dv dx. By the chain rule, I differentiate with respect to the brackets first. I get 2 times 4 minus 2x. And then I multiply by the derivative of what's in the brackets, minus 2. So that comes out to be, I'm going to leave those brackets there for the moment, and I'll say that that's minus 4 times 4 minus 2x. Right, quotient rule says that dy dx is equal to v times du dx minus u times dv dx all over v squared. So I have v, which is 4 minus 2x to be squared, times du dx, which is 15 times sin h of 3x, minus u times dv dx. So u is 5 cosh of 3x. dv dx is minus 4 times 4 minus 2x. All that over v squared. V is 4 minus 2x to be squared. So v squared is 4 minus 2x to the power 4. So we're almost there. Again, I will divide top and bottom by a factor of 4 minus 2x. So that one is gone. That 4 comes down to a 3, and that 2 is down to a 1. So I'll multiply out what I have left, and I get that that is equal to 60 minus 30 times x times sine h of 3x plus 20 times cos of 3x, that's minus 5 times minus 4 is plus 20, still all over 4 minus 2x to the power of 3. And there's nothing more we can do with that. That's the answer. Okay, another big long one here, part 6. We'll do it one element at a time. So, inverse tan of 3x. Well, the derivative of inverse tan of x is 1 over 1 plus x squared. So, that's 1 over 1 plus 3x to b squared times the derivative of what's in the brackets, which is 3. Then I get minus 5. Well, the derivative of cos of x is sinh of x. So here I'll have sinh of 2x, and by the chain rule it'll be times the derivative, which is 2. X, the cubed root of x, this is going to be minus something anyway. The cubed root of x is x to the power of 1/3. So I'll get minus 1/3. Power comes out in front. 1/3 minus 1 is minus 2/3. So it'll be x to the power of minus 2 over 3. So that 1/3 is the power that came down. The cubed root of x is power of a third. And then I take away 1 from 1/3 to get minus 2/3. That becomes the new power. On this, the minus 4 comes out in front, and I get e to the minus 4x, just like the last one of these that we had. And the log of 4x, well, I get 1 over 4x times the derivative of what's in the brackets, which is 4, is equal to, that comes 3 over 1 plus 9x squared, minus 5 times 2 is minus 10, times sinh of 2x. We get minus a third, x to the power of minus 2 over 3. You could just leave it like that, or if you want to be fancy about it, you can say that's 1 over, that 1/3 is there. X to the power of minus 2 over 3. The minus brings it on the bottom. The third is the cubed root. I would leave it like this actually. In fact, it's probably not even worth making that move. I'd probably leave it as minus 1/3 x to the minus 2 over 3 really. That's fine. So we say minus 4 times e to the power minus 4x. And the 4's cancel on that one, and it's just 1 over x. And that's part 6. Part 7 is another awkward quotient rule one. So we'll do that out now. So we'll say that's equal to u over v, where u is equal to twice the inverse sine of 3x. So straight away we'll get du dx. It's going to be 2 times. Look in your maths tables, you see the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. So I'm going to get 1 over the square root of 1 minus 3x to be squared times the derivative of what's in the brackets by the chain rule, which is 3. So that comes out to be 6 over the square root of 1 minus 9x squared. Then v is equal to 2x plus 5 to be squared. So that implies that dv dx, again a chain rule, we differentiate with respect to what's in the brackets. So we get 2 times that, and then times the derivative of what's in the brackets is 2, which is 4 times 2x plus 5. And I won't multiply that out yet because I know I'm going to be able to divide by 2x plus 5 later. So on we go. We say that dy dx by the quotient rule is equal to v times du dx. So that's 2x plus 5 to be squared. That's v times du dx, which is 6 over the square root of 1 minus 9x squared, minus u times dv dx. So u is 2 inverse sine of 3x times dv dx, which is 4 times 2x plus 5. And all over v squared, which is 2x plus 5 to the power of 4. So here again I can divide top and bottom of my fraction by a factor of 2x plus 5. So I divide that term on the right by 2x plus 5, this is gotten rid of. I divide the term on the top left, and that becomes a power of 1. I divide the bottom by 2x plus 5, and that becomes a power of 3. So now we'll multiply this all out. 2x plus 5 times 6 is 12x plus 30, and that's over 1 minus 9x squared. Then I have minus 2 times 4 is 8, times the inverse sine of 3x, all over 2x plus 5 to the power of 3. Okay, that's a big awkward question, kind of, but it's really just a matter of applying the quotient rule and then breaking down my u and v derivatives with the chain rule. And there it is. Another big long one here, but it's an easy enough one. I'll go straight into it, piece by piece. The derivative of inverse cosine of x, you've seen it before, it's minus 1 over the square root of 1 minus x squared. Here we have 5x, so it's minus 5x to be squared. Don't forget to put that in brackets. Times the derivative of what's inside, which is just 5. Minus 4. The derivative of sinh is cosh, so it's going to be cosh of 3x. Chain rule, the derivative of what's inside is 3. Root of x is x to the power of a half, so I get my half times x to the power minus a half, like I've had before. This is all very familiar at this stage. I get minus 4 times e to the power of minus 4x by the chain rule. And finally I get plus 5. Derivative of log is 1 over, so I get 1 over 3x times the derivative of what's in the brackets, which is 3. So I can sort this out now and say that's minus 5 over the square root of 1 minus 25x squared. It's 25 because I have 5x to be squared, so that's 5x times 5 times x. So I have 2 5's in there, makes 25. 4 3's are 12, so we minus 12 cosh of 3x minus 1 over 2 times root x, so x to the power of a half is 1 over the square root of x, minus 4 e to the power minus 4x, plus those 3's cancel, I end up with 5 over x. Right, the last one, part 9, another big awkward quotient rule. We go straight into it. That's going to be u over v. So u is 5 times the inverse cosine of 2x. So that means that du dx is going to be 5. Derivative of inverse cosine is minus 1 over the square root of 1 minus x squared. Well, here we have 2x, so it's going to be 2x to be squared, and by the chain rule we multiply on that derivative at the end. So that comes out to be minus 10 over the square root of 1 minus 4x squared. V is equal to 3 minus 5x to b squared. So dv dx, another chain rule, the derivative with respect to the brackets is 2 times 3 minus 5x, and then the derivative of what's in the brackets is minus 5. So that comes out to be minus 10 times 3 minus 5x. And I won't multiply that out yet because I know I'll be able to divide later. Finally, dy dx, by the quotient rule, I get v times du dx. That's equal to 3 minus 5x to be squared. That's v times du dx, which is minus 10 divided by the square root of 1 minus 4x squared, minus u times dv dx, where u is 5 inverse cosine of 2x times dv dx, which is minus 10 times 3 minus 5x, all divided by v squared. So v is 3 minus 5x to be squared, so I square that again and I get the power of 4. Now once again, I can divide top and bottom by a factor of 3 minus 5x. So that 2 becomes a 1 to the power of 1, or it's just gone, the power. This one is gone completely. It goes to a power of 0, which is just 1, disappears. That power gets reduced to a power of 3, because we divided by 3 minus 5x. So we're almost there. Tidy all that up and multiply it out. So I have 3 minus 5x times minus 10. That is minus 30 plus 50x. And on the bottom I have the square root 1 minus 4x squared. Then minus 5 times minus 10 is plus 50. And I have my inverse cosine of 2x there. And it's all over 3 minus 5x to the power of 3. And that's that. That is question 8 on exercise sheet 3.